Good evening, guys, and welcome to Placid Lesson. Today we shall be learning physics, and under physics we shall be studying EMR, which is electromagnetic radiation. And under electromagnetic radiation, we shall be studying definitions and the general properties and essential features of EMR. Now, what is EMR? Electromagnetic radiation, which is EMR, is the ubiquitous phenomenon. When I say ubiquitous phenomenon, what I mean by ubiquitous is something that is existing everywhere. It's the ubiquitous phenomenon that takes the form of self-propagating waves in a vacuum or in a matter. It takes a type of energy that typically combines simultaneously traveling electric and magnetic wave. When I say simultaneously, I mean it combines magnetic and electric wave at the same moment while they travel through a vacuum or in a matter. Now, the field of electromagnetic radiation is one of the important areas of physical and material science, partly because it plays a role in detecting and measuring material properties that we don't always encounter. Now, what is field? Field is a physics term for a region that is under the influence of some force that act on matter within that region. Now, under the field of EMR, it is a region that is under the influence of electric and magnetic force that act or radiate on matter within a region or a vacuum or a particular area. Now, the properties and essential features of EMR. Apart from traveling simultaneously, this electric field and magnetic field components that compose EMR oscillate in phase perpendicular to each other and perpendicular to the direction of energy propagation as shown in the. This is a diagrammatic illustration of electromagnetic radiation and its properties. You can see here, this is the electric field and this is the magnetic field, and this is the distance. The electric field goes vertically up and down, and the magnetic field goes horizontally left and right. And right here you can see the wavelength, which is the distance between each successive peaks. Then the frequency is the point at which this electric and magnetic field intersect, and each of these points is the number of cycles per second passing a fixed point. Then the direction which this thing goes is also the velocity of the light. You can see the velocity at the direction of the propagation. Now, these are some of the properties of EMR: the wavelength, the frequency, and the velocity. Now, the figure below delineates a plane polarized electromagnetic radiation, which comprises a single oscillating electric field and a single oscillating magnetic field. There's a diagram I'm going to upload right now. Here you can see the plane polarized electromagnetic radiation showing the oscillating electric field in blue and the oscillating magnetic field in red. The radiation amplitude A and its wavelength are shown. You can see the one in red is the electric magnetic field. It's actually moving vertically up and down, and the magnetic field in blue is actually moving horizontally left and right. And the amplitude, which is the height of the electric and magnetic field, and you can see the wavelength, that is the distance between each successive peaks. And the distance between these successive peaks here is in the electric field. You can see it there in red. Then the one pointing by the right is the direction of the propagation. That is where they are going to. There are other several fundamental properties of EMR, which include its velocity, amplitude, frequency, phase angle, polarization, and direction of propagation. Thanks guys for watching, and that will be all for now. So if you experience any difficulty or you don't understand, you can message me on WhatsApp from 09135705008 or 09074719810. Thanks for watching. Bye. See you next time.